What's up, everyone? This is Ryan here, and I am super excited to kick off part 2 of my lesson series. In this part, we're going to be talking about different software architecture ideas, and we're going to do the actual sort of Java coding and all that sort of aspect of the application building process. And yeah, so let's just kind of jump in here. What we're going to be talking about in this video is, for starters, figuring out the problem domain and also figuring out sort of getting our heads wrapped around how we're going to be applying model view presenter design architecture to our application and just the concepts in general. So yeah, in 1.4 I briefly mentioned that there was a step that I skipped in the design process, and I like to call this step the problem domain, and that's what we'll be talking about. So there's basically two parts to the problem domain, at least my interpretation of it. So the first part is there's two questions you need to ask. The first question is, what data does the application need to represent? So in this case, we're working with a calculator, and the reason why I chose the calculator is because the problem domain is minuscule. So I don't actually really need to be, I'm not going to be telling you anything that you don't really know, but I just want to walk you through the process so that you can apply it to more complicated situations or newer app ideas that you might be working on. So, first question, what do we need what kind of data do we need to represent in our application? For the calculator, obviously we're going to need to represent an expression in some way. So, there's a couple different ways that we could have solved this problem. One of the ways could have been having a variable for the first part of, basically, let me just put it this way. One way is we could have broken up the expression into, for example, number values and operators, and sort of tokenize them, for lack of a better word. And that is absolutely a valid way of solving this problem. But what I ended up doing is I found a library which accepts just a string expression, and that's what we're going to end up using, because that way we don't actually have to reinvent the wheel and write out all of these calculations. So with that in mind, I decided that all we're going to need to represent our data in this application is a string called current expression. And that's all we need. And let me tell you, that saves a lot of headaches. So the only other question we need to ask when it comes to the problem domain is, what do we need to do to that data? How do we need to manipulate it? So in the context of the calculator, obviously we're going to need to append operators, decimals, numbers to the current expression. We're going to need to delete numbers, operators, and decimals from the current expression. We're going to need to evaluate the current expression, and we're going to need to display the current expression. And that's really all we need to do. So yeah, that's basically an overview of what the problem domain is for the calculator. So the next thing we can do is, with this information, we can then start to reason about what our user interface is going to look like. And I'm only going to briefly talk about the UI. That's not really the topic of this video here, but just to give you a quick overview and explain some things that you guys don't really need explanation for, is that after I sort of figured out all of that information, then what I was able to decide, obviously, is, okay, well, we're going to need buttons for numbers, operations, and decimals. We're going to need a delete button, an evaluate button, and we're going to need to display the current expression. So that's really, once you know those things, that's when you can start getting into sketching and figuring out, okay, well, where am I going to put these different components of the user interface? So yeah, that's basically my spiel on the problem domain and how it can help the design process. But what it also does is it sets us up for the sort of more software architectural design of our application. And so that is sort of a prior step to that as well. And that's what we'll be talking about next. So what we're going to be talking about now is the MVP, or Model View Presenter architecture. I do apologize in the video if I randomly say MVC just by habit, but yeah, that's basically what we're going to be talking about. So one thing I need to mention is that I did a video on multi-layered architectural designs earlier in this lesson series. If you haven't watched that, or you just don't know anything or have no experience with design architectures like MVC or anything like that, you are going to want to watch that video because this is not something you can really just jump into and sort of understand it right from the get-go. At least that wasn't the case for me. So I'll put up a little annotation here that you can click. Please do watch this video, watch that video first, and then when you get to this video, if you have questions, just be sure that you look at that resource first, because you're going to need to. Anyways, what we're going to be talking about is Model View Presenter. Now, before I get into the specifics of it, I have one big thing which I really need to mention, and this is super important because we'll be running into this in our own application. Design architectures should be used as informed guidelines, not hard rules. So what I mean by that is that every problem is going to be different in some way. And by problem, I mean, let's say if you're building a calculator, it's going to have a particular set of problems you need to solve. If you're building a note-taking app, it's going to have different problems. So the important thing to realize here is that you want to base your designs on these architectures, but you're going to run into situations where it doesn't necessarily make sense to follow it explicitly, and there's nothing wrong with bending the rules a little bit and deviating, as long as it's an informed decision. I'm not saying you should just throw it out the window, obviously. It's just, in the case of our app, we're not actually working with a database, which is normally what a model is, so things are going to change a little bit based on that. So I just want you to be aware of that before we jump into things. So first things first, the first part of the Model View Presenter architecture that I'll be talking about is the view. So instead of saying, well, let me just put it this way, what I like to do and what I strongly recommend is I read a book on design patterns at a certain point, which is something that I'll talk about just in other videos. And one of the main lessons I took from it is you want to think about these different components of design patterns and like software architectures as having responsibilities, and that's really key. So what are the responsibilities of the view in the Model View Presenter architecture? And I also need to stress that this is my interpretation of it. Please do check out other sources. There's going to be different interpretations of how this works. This is really just the way that I think of it and the way that has been useful to me. So the first thing is the view is mainly going to be concerned with drawing things on the screen. So obviously, like, the view is going to contain our text view, which is the display, and it's going to be responsible for setting the text on the display. Obviously, it doesn't make sense to do that elsewhere. The view is also going to be responsible for forwarding user input events to the presenter. So whenever the user clicks on any part of the view, any of the buttons, then the view is going to be responsible for telling the presenter, which we'll get to next, hey, this just happened. Now, here's where things get, again, a little bit foggy. What I've chosen to do is I don't check the input at all in the view, at least as far as I'm aware. Hopefully I don't have to make an addendum to that, but as far as I can recall, I don't check the user input. Now, that's something you might arguably do. You could plausibly do that in the fragment class if you wanted to. Like, for example, if someone hits the equals button and it's obviously not a valid expression, you might actually be further ahead to just handle that in the view. There's arguments to be had about that. In this case, I've chosen to keep the view as dumb as possible, so all it does is pass those events, the click events I'm speaking of in particular, to the presenter, and then it lets the presenter decide what to do with it, whether it's valid or invalid or anything like that. So again, that's one of the scenarios where if it makes sense to do it a certain way, then fucking fly at it. Anyways, yeah, so how does this sort of fit in with our application? Well, obviously, in the earlier videos, we created two fragments, display fragment and input fragment. And one thing that's awesome about fragments is that they lend themselves very well to Model View Presenter architecture as views. They're basically designed for those two things that I just described, drawing things on the screen and handling user input. So yeah, that's basically all I'll say about the view. Next we have the presenter. So, what are the responsibilities of the presenter? Well, it's going to handle messages from the view and update the view when appropriate, obviously. So that's the first thing. It's also basically going to do the same thing for the model. It's going to either pass the appropriate data to the model and say, hey, you need to save this, or it's going to receive data from the model that the model has fetched and figure out what to do with that data. Usually what's going to happen is it's going to either just send that data directly to the view, or it's going to manipulate it first and then send it over, whatever needs to happen. And also, generally speaking, your presenter is going to handle the application's logic. What do I mean by that? Honestly, it's just kind of hard to describe, but just think about the fact that if our view is only going to be responsible for doing like two things, and if our model is going to be responsible for doing like two-ish things, then the presenter is going to try and do everything else. Let me put it that way. So yeah, in our particular application, we're going to be building a dedicated calculator presenter class, and it's going to act as a go-between for our model and our view, and it's going to do a lot of the thinking. Now, our model is a little bit weird, and that's what I'll get into next, and it's actually going to do some of the things that might arguably be better for a presenter, and I'll get into that why in a moment, but again, like these are general rules for this stuff, and hopefully it makes sense. So the last part of the model view presenter architecture is the model. So what does the model do? It basically stores data in an appropriate format, pardon me, and it also fetches and forwards that data to the presenter when the presenter asks for it. The only other thing it really does, and it's almost not even worth including this, but it's going to obviously tell the presenter, hey, this write operation failed, or hey, I didn't find what you were looking for, but it's not going to do anything beyond that. It's the presenter's job, again, to interpret that error code or error message. So our model is a little bit weird because we're not really working with actual storage. Like, our current expression is really only stored based on the activity's life cycle. It's not like maintained in a shared preference or anything like that. So it was almost kind of how can I put it? What I decided to do is I decided that our model is actually almost, it's going to be smarter than it normally is. The model is not only going to be our current expression variable, it's going to sort of maintain that, but it's also going to be responsible for performing the calculations on current expression when necessary, and also sort of basically what's going to happen is the presenter is going to pass either a digit or a variable, sorry, not a variable, either a digit or an operator or something like that to the model, and the model is actually going to be responsible for appending that to the current expression. Now, obviously, that doesn't make a whole lot of sense if I just finish saying that you should be handling shit like that in the presenter, but obviously, like, understand that we're working with a special kind of unique situation, and for me it made more sense to handle that stuff in the model. Why would I say that? Well, for starters, if as we'll see with this calculation class, which is basically what's going to be our model, if I were to include all of those operations in the presenter, then the presenter class would have been a lot larger than I really like to see. What I preferred to do in this particular situation is make the presenter mostly just the go-between for the view and the model, and really just keep it at that, and have the model do a little bit of have it do calculations. Let me put it this way. So anyways, I think hopefully that gives you a pretty good introduction into Model View Presenter, and also how that's going to work with our Android application. If there's any criticisms or questions you have, please feel free to let me know in the comments or hit me up on Facebook about that. And yeah, that's basically it. So thanks for watching. Don't forget to like and subscribe for more awesome content. And in the next video, what we're going to be talking about is, for starters, I'll be actually writing the view, and basically that means writing our fragments. And I'm also going to show you about a really fucking awesome library called Butterknife, made by this dude named Jake Wharton, who's like a super amazing Android developer. And we're going to see how that's going to really save us a lot of trouble when it comes to handling the input from something like 18 different buttons or 17 different buttons. Anyways, that's all for now. Thanks for watching, and I'll see you later.